Yesterday, before I went to sleep, I did a little bit of upscaling, and then something hit me, and I realised, well, obviously, as you know, because when I print large round objects on the print bed, the problem with that is that things tend to come out slightly ecliptic, as in oval shaped or not quite round. Well, that causes you a lot of balance problems. So I was modelling this last night, but this is just representative. I just wanted to get a feel. For it, and I'll explain some important things here. Now, where's my pizza slice? You'll see that in a minute. It's kind of funny, right? So because this wheel is so big, I had to divide it into. Well, there's actually 9 segments on here on this drum. I'll go to the actual drum over here. Now this actual drum is. Let me just put my phone in the stand. That's probably the best thing to do. Then I won't be jerking around, and I can zoom in and everything, and save me having to go on the live stream from the computer. So let me just see if I can zoom this in a minute without stopping it. Oh, you twat! You've switched cameras again. I don't want to switch cameras. I want to zoom. Hang on a minute. Let me just zoom in first. This is stupid. When I use my fingers to zoom in, it keeps switching to the other camera, and I'm not even near that bloody button. Right, just a minute. Right, so I've got it zoomed in. Sorry about the wobble. I'm going to put it in the stand. Right. Okay, that should work. Back it a bit more. I'm tilting it back at the moment, so right. So that should work without it jumping around once it's. I'll leave it a minute. So, I'm tilted too far back now. Alright, that's alright. So, right, that's the drum. Now, I'm using the segments as placeholders. So, that is not going to be the way they're orientated, and I'll explain why in a minute. You can't have them orientated like that. But the actual width of this drum is 204. I don't think you can see that. But 204 millimeters. It's basically wider than my print bed. So because of that, I had to basically pizza slice it into sections, which would mean that I would have to print out these little pizza slices. I call it a pizza slice because it's like a pizza. And then I started thinking about this a bit more, and I realised that there was going to be a problem because the amount of pizza slices that it would take. I've got to put, obviously I have to put Lego couplers on there to intersect, just like I did with the previous one. But I kind of abandoned it at this point because I thought, the more pizza slices I have, the more trouble there's going to be with errors creeping in, and the whole thing is going to end up not being the right shape. So I mean, with 3 pizza slices, yeah. So what I'm going to do is basically scale this thing back down a bit, and I'll explain some important things about this thing. I'll have to use my phone to point directly at that. But when I scale this up, I went and messed up the canopies for the coil holder because I only had one canopy at the bottom of this thing, and I scaled it up, and I realised that all my drum and everything was off centre, and I realised it's because the canopy was creating it wasn't scaled up in a linear fashion from the centre. It was scaled up from the centre axis between the bottom of the canopy and the top of this structure, so it all came out warped anyway. It was a total mess. So. And this holder, the stand that it's on, this stand is, if I measure it, it's actually 251 millimeters long. That's basically about 60 millimeters wider than my print bed. Well, obviously I would have to split that as well. It's just giving me a headache. I really don't want to go. I don't want it to be to the point where everything has to be split into little chunks. Even this thing in the middle that holds magnets. Now, I was going to go with a 20 millimeter wide magnet. So if I measure between that corner there and this corner here, that is 20.1 millimeters. Now I was going to use the 20 millimeter magnets, and that was what was determining how large I have to scale it. Well, I've since decided not to use the 20 millimeter magnets because they're becoming a bit of a constraint on the design because of spacing and everything else. So today I went to the post office, I put some money in, and I ordered 50 neodymium 8 by 25 by 8 by 2 millimeter magnets, which is the ones that I was using in my big those drums that I was showing you that are balanced, that I don't want to dissolve in acetone. Those type of magnets, I've ordered 50 of them. It only cost me like 15 quid, so that's 15 pounds UK sterling. So they're not that expensive. So they should be here in a few days. So instead of having 20 millimeter wide slots, I will have 8 millimeter wide slots, which is going to be massive, because if you think about it, all this adds up. So if you've got 20 millimeters there, 20 millimeters here, I don't know if you can see my cursor, it's probably so tiny. What I'm going to do, because it's hard for you to see, I'm just going to grab a text box a minute, because I don't know if you can see my cursor moving around. I'll just get this text box a minute. I'll shrink it as small as possible because I'm going to use this text box so you can see better. So if we've got 20 millimeter magnets here and we've got 20 millimeter I'm cheating a bit, I know, it's a pretend cursor 20 millimeter magnets, all of this adds up to the circumference, right? So it messes up with spacing. All of this circumference means that's got to be really big to accommodate them big magnets. Now because I'm going to go to the 8 millimeter wide magnets, that means I can scale this thing back down again and still have 3 sections that are doing the polarization and the magnetic drive. Just minimize that. Next time I open a text document, I'm going to say, where the hell's my text? Because I've shrunk the damn thing down, so I'm going to make this big again. Oops, wrong one. Yeah, I'll just get rid of that. Anyway, so I've been thinking about this all night. Now, there's a very important thing about this rotor, these laminations. I mean, you can't have them just like that because it's not going to work, and I'll explain why in a minute. These magnets, if you remember, these magnets are permanently on, right? So there's a magnetic field permanently traveling through here, and the coil is stationary, right? And the magnets are stationary. So the only way we can generate power as and you have to use the steel laminations in a certain orientation to basically pulse that field across the coil, and at some point you need to short the field out. So this is why I need to explain that, and it's very important. It's definitely a factor. If you don't manipulate the magnetic field, you will not generate any power. So let me just go to the other one. I think I'm saving it just so I can switch over to the original one. Right, so I'll go back to this one. Now, one thing I realised about this, I was thinking last night, was because my laminations, the steel, if you look at the design, are actually pointing outwards in this orientation when they're adjacent to the magnets. When they're pointing outwards and the magnets are just directly opposite the steel laminations, we have a magnetic gain in the field for the coil, and we're directing that flux in this arc. Maybe I should have kept that text document up. Can you see my mouse? I don't know if you can see it or not. I'm just going to use something else actually. I'll just use a pointy stick. So the magnetic field is moving from there to there, and we get a big arc of magnetic flux coming out around here. Now, when the rotor is in the other orientation, when those two are together, when these two are closer together, this one is close to that one, we short out the magnetic field, which is what we need to improve. So what I'm going to do with the next design is I'm going to bring this one here and this one here closer together so there's no white space in the middle, because that will effectively short the field out, because you have to collapse the field and then raise the field to create your AC waveform, otherwise you won't have any output. So the reason why I was getting a lot of current and very little voltage is because I wasn't collapsing the field sufficiently in this area, and this area needs to be folded around so that the magnetic field from that, say the magnet there, is folded around and cancelled out. Obviously this rotor is in the wrong orientation, it needs to be adjacent to the magnets. But so the new design, I need to basically go in threes, so it needs to be either three of these, 6 of these, or 9 of these, right? So that's what I've been working out, but I could go up in 2s, I suppose, but no, not really. It's not practical, because I want all 3 sections up opposite the magnets all at the same time. So we've got 3. So we've got an in-phase generation, so we can actually wire them in series if we need to do, or in parallel if we need to do. So that's the reason why I'm thinking in terms of 3, 6, or 9. Because if we have an odd number, that means that one of these rotors is not going to be opposite the magnets, right? So that means it's not going to be doing anything. We're going to have phase problems, and yeah, you get what I'm saying. I'm out of breath now, all this talking. So I'm going to take my phone out of the stand. Oh, not pushing any buttons. So going back to my drawing. So what I was doing yesterday, well, this morning actually, I was testing some other theories out with 2 of these segments, and actually I'll bring the stand over here again, just a minute. I'm probably making you drunk now. Put it back on the stand a minute, and I'll try and show you what I mean. So if I get 2 magnets, is this, oh, it's droopy cam again. We get these 2 magnets, and I put 1 magnet. Where's the camera? Oh, it's because I zoomed in, isn't it? Ah, yeah. Put 1 there, 1 there. Let me just zoom out again, just a minute. I zoomed in, and I need to zoom out without switching cameras. I'll do it. Oh, that's in. Sorry, I'm very bad with doing this. I'm not very proficient with zooming on this camera. So if I get this segment and I have 2 different fields, I'll put 2 round magnets. This is what I'm talking about. These 20mm magnets are massive. They're just too big for this project anyway. So obviously they're both sending the field through. Now we get a good amount of flux, 1 here, and that one's pulling in, that one's pushing out, when they're splayed outwards like that. So that's when we have our maximum flux gain, when it's like that. But when we put 2 segments next to each other, they're actually folded inwards, and they're actually pointing towards each other. If you look, that's when we cancel out our magnetic field. So if I bring those magnets around like that, that's where we get our collapsed field, because we're collapsing it, because we're effectively, well, we're not screening it, but we could use that nanocrystalline core material to screen it, I suppose, but I would require quite a lot of that, and I'm going to have all sorts of problems if I start using that now, because of the balance problems, if they're not all exactly the same and everything else. So I'm just going to stick with this material for now. But when these are coming together like that, we effectively cancel out most of that flux. So if I get my gauge again, right, we still have some flux pointing out there, but most of it is cancelled, chopped off right in the middle there. Look, it's actually nulled off there, because it's meeting the negative side, because right in the middle, right in the centre there, it's effectively a null field. As we go around, we start to see it. So obviously my laminations are not orientated right, the laminations have to be orientated in such a way that we have maximum cancellation when the two come together. So I have to rearrange these on the SketchUp model so that when the laminations of these steel shims close together, we cancel it out. So that gap that I've got there with these big hollow sections, they need to be filled, right, with some shims, or we need to have another shim in there to collapse the field in the middle more, so that when the magnets are actually positioned onto in that position on the segment sections, we actually get a bigger gain in the middle. So this gravity is interfering with this thing. These balls are pretty heavy. I was saying them words again. Right. So that's where it's pulling there, and that's where it's pushing there. Right. So you get the idea anyway. So anyway, I'm going to be messing about scaling. I'm not going to bore you with live streaming it because it's a very tricky, painful thing trying to scale everything and work out the flipping. Oh, this phone's going to fall off in a minute. Because last night when I was trying to scale that thing up, I just got into all sorts of trouble. I mean, I got warps and all sorts of problems, and I ended up having to go backwards and undo a lot of stuff. And as I say, I overlooked the canopy problem, and because the canopy was mounted on the bottom on this one, because I copied this one across to the other one, and when I scaled it up, it all came out warped because the canopy was attached. I should have removed the canopy first, scale that up separately before I scaled it up. I should have removed the stand and the canopy at the bottom and just scaled it up that way, but without scaling up the actual red parts, you know, the lamination sections, because they're going to be the same size, but the actual curvature is going to be obviously shallower. It's not going to be as round, it's going to be flatter out like that because it's on a larger diameter rim. So yeah, it was such a pain, it really was. But yeah, I'm going to copy this over to the other, to a new file. Or I might go back to the more scaled up because I fixed most of the problems with that now, and I'm going to scale it down, and yeah. But I've got to get it right. I've got to get it right because I've got plenty of filament now since I got that new spool. We've got plenty of filament, but I don't want it to all become junk. I don't want to waste all my plastic on something that's going to not work. So yeah, anyway, that's where we are at the moment. Right, thanks for watching.